Hi, very good morning to you. It's Jim from maverickstar Observatory. What I wanted to do in this video is just simplify things a little bit even more, and to do that I've put a barbecue skewer through the Earth, the globe, and we're going to talk about the tilt in relationship to the seasons, mainly summer and winter. I know a lot of people already get it, but I just thought, we could simplify it a little bit more to understand what's going on with the Milankovitch cycle. And now, yes, only 1,000 miles can make a big difference between us being in an interglacial and a glacial period. So maybe a bit later on we'll put this on the barbecue and we'll demonstrate what happens in a CME, coronal mass ejection. Maybe we'll get Ben Davison to go over his supernovae or micronovae theory of that. So our Earth is at around 93 million miles away from the sun, and it's really strange to think that even at that distance another 1,000 miles would make any difference whatsoever, but it does clearly, and we can see that with the poles on our planets, the Arctic and the Antarctic. The reason why they've got ice on there is because as our Earth travels around the sun, let's say this is the sun, as it travels around the Earth on its tilt, it puts the northern hemisphere, as it would be now, in the winter, and the southern hemisphere in the summer. And as it goes round our Earth, another 6 months later, you can see the angle hasn't changed, but the amount of sunlight now that the northern hemisphere is getting is much greater. So, in the winter on that side, and then back in the summer this side. And it's just that little tilt of our planet that creates the situations for ice to form. Now, the Milankovitch cycle happens every 100,000 years. It puts us on our orbit around the sun. It puts us a little bit further out at 50,000 years, which is around about another 1,000 miles out. So you can imagine now, as we travel around the sun on our tilt, at the winter time over the northern hemisphere now, the Earth's over 2,000 miles further away from the sun, so it's getting even less sunlight and heat. And then again, 6 months later, the southern hemisphere is getting the same. The reason why we have these ice accumulations on the northern and southern hemispheres is solely down to the angle at which our Earth rotates, which is around about 23.45 degrees. But you can imagine, when the Earth is there at 23 degrees tilt to the Earth, it's putting it in the summer, when it goes back over there, it's almost like the Earth has gone, from that angle to that angle, although the angle doesn't change, but its situation to the solar plane has. If I just do it that way, you get an idea. So, we know that we've come to the end of an interglacial period. We're about 6,000 years into the 50,000 year approach to maximum, which is when our sun is another 1,000 miles away, and in our winters we will be 2,000 miles away from the sun. So that's why we get glacial periods, and that is what we're merging back into. We're about 12% already there. Now, I said in the video yesterday, we also had some other issues that are of concern that could probably bring about the glaciation much faster, and that is because of the jet streams that have been interfered with the cosmic rays as a result of low heliosphere or weakened heliosphere, which is like a bubble. If this was our sun, there's an inflated bubble that goes around our solar system, and it pushes away a lot of cosmic and galactic cosmic radiation and intergalactic cosmic radiation, or outer and inter, away from our solar system. So we have a lot more solar rays or cosmic rays inbound for that reason alone. And then our Earth's magnetosphere, which is our primary protective field, is being reduced because of the Earth is going through a magnetic reversal. So we have a lot of interaction in our upper atmosphere and as a result of that, it is modifying the jet streams to the point of dislocation and fracture over the northern and southern hemispheres, and that, along with the Milankovitch cycle, could put this Earth into a rapid glaciation, and we might not have to wait till we get to, you know, the full 50,000 years before the Earth, or the northern hemisphere and the southern hemisphere, is covered in a lot more ice and snow. The big problem is with this is, as I showed on that temperature chart, I know a lot of people couldn't actually see the names, but I think if you could see the content, the continent lines, you knew which geographic locations we was talking about, which would be affected. And we're already, if we just a bit later on cut the feed that you're looking at now and go and have a look at the globe, we'll see today, or you could go over to North School yourself and have a look at how much of the northern hemisphere right now is covered in sub-zero temperatures. And, you know, I said that, you know, it won't be long before perhaps that sub-zero temperature is covered in a white frozen layer, which could then begin to build up over many years after that. Some people in the comment section on yesterday's video, and it done 9,000 views, which I'm really happy about. I'm also really happy about the amount of subscribers we've had recently, around 9,000. That's amazing. But, you know, even though we've got these extra people here, the levels of support are still low for this channel. You know, about 3 people yesterday pledged a little bit of financial support for the observatory, which, when you consider 9,000 people viewed it, and then, you know, you consider nearly 15 to 20,000 people viewed the stuff that we've got on the website, we're not doing too good with regards to raising funds for this observatory. I want to thank those that are supporting it, even though they're in very few numbers, and you can count them on one hand, you know, over a couple of days. I want to also thank, you know, we've got some great superstars. Scott McDonald from the United States in Tucson, Arizona, has sent us his data, which we'll be processing later on, and we'll be talking about tomorrow in an upload for you guys. But we could have a lot more equipment out if we just got a little bit more support, not just from people that are willing to have our equipment out in the field, but for people that are prepared to pledge a little bit of financial support for the observatory, because, you know, we are all in it together. You know, we all live in some form of monetary system, and, you know, I can't go and buy electronics on good faith. You know, it just don't happen. Just to give you an idea, some of the some of the electronic components, like the SIPM, the silicon light receiver that we put in the muon detectors, is £118 each. And we're very lucky that the supplier will sell them in just ones and twos for us, because otherwise you'd be purchasing those in the thousand, which is how they usually sell them. So we're lucky that they will supply now and then, you know, few numbers for us. Otherwise we just wouldn't have them. And off the top of my head, I think it would cost us around about £7,000 per unit if we were buying them and not manufacturing them here at the observatory ourselves, like a lot of other equipment that we do manufacture, like our magnetometers that people like Scott, Kendall and Jeff in Australia have for us. What I did mention yesterday is something I think we should talk about. You know, I can give you all this information, but whether you act on it is another thing. We could, in the not too distant future, start seeing mass migrations if things do accelerate to a rapid point of glaciation on this planet. We could see mass migration. And some governments are going to lose their continuity. And, you know, it's not just going to be Canada. Canada is definitely one of those continents that is going to be massively affected. And I know people probably watching this now in Canada is thinking to themselves, you know, we handle heavy winters already and we do a reasonable job of it. But I just don't think you're aware of the extent of the winters which you are going to be handling. And if we look at just how your infrastructure has been affected, and I'm not just picking on Canada, because we've seen the same happening in those northern European countries, even those central European countries. We've seen it happening where these floods have just washed away the infrastructure. Just to mention that one in Vancouver where it washed away the railway, and I bet you they haven't done nothing about the fix the tracks yet, because I said this was going to be a big engineering problem to resolve, and you can't just pluck bridges out of nowhere to repair those rails, and of course road infrastructure as well. But it isolated Vancouver dock, leaving billions and billions of pounds worth of produce there. You know, it's not just Canada again, it's not just the United States, and here we are not out of trouble even in here, because we're going to see some dramatic changes to our climate seasonally here in the UK, and the only thing that is stopping that at the moment is the intensity over Canada, because once that intensity dissipates, it doesn't even have to do it quite that much, but it will dissipate, but it will change the magnetic intensity over the northern hemisphere, and it will plunge us into those shocking sub-zero temperatures that we've seen in North America and Canada, and we always see them year in, year out. What I'm trying to say here is that we are gradually going to see an extension. If you haven't already experienced it as a farmer in Canada, you're going to see an extension to the winter, extending longer periods of time, and that will be, you know, there's nothing we can do about that. The only thing we could do about that short term would try and support the infrastructure that supports many millions of people in these continents that are going to be affected. Like, you know, we might need to consider moving all the electrical pylons that move along the countries above ground, underground, because when they have massive accumulations of ice building up, they're going to snap, and it's going to render cities out of power. And, you know, when the grid goes down, you know, it just doesn't affect the lights coming on in your house. It affects the fuel being pumped at your stations, and then it has a knock-on effect on the logistics. So there's no food, there's no sewerage coming out of the cities, you know, there's no water being pumped into the cities, there's no fuel for your cars, and other infrastructure starts to fail around it. So that the grid really is one of the things that these governments need to be investing heavily into. But I'm going to find it really difficult to see that ever being the case now, because of how much they've committed themselves to global warming and carbon taxes. We're already starting to see them do about turns in Europe, and Germany are trying now to get gas power plants and nuclear power plants stamped with green energy, because they simply can't cope with energy demands at the moment with the renewables. The thing is, renewables are going to be a complete waste of time over these territories above 40 degrees in any case, because when you have prolonged frosts on solar panels and prolonged frosts on the blades of turbines, even if they're heated, it's a waste of the electricity that they create to start with. And I mean, we all know, you know, I have a regular subscriber who sends me these things in emails, tells me how inefficient they are, first of all, with their unenvironmentally green production methods of these things. You know, they're not sustainable, and the energy that they produce it's petty. So, you know, they've got to do something, especially if they expect us all to convert to electric vehicles at some point. They have to do something, and I think that what they are now realistically looking at is bringing nuclear power and gas power plants under the green stamp, so that they become they're categorised as green energies when we know they're not. But, you know, there's a lot of trouble coming our way, and I don't think we can physically cope with it. And therefore, I can only say that we are going to see, probably in the near future, mass evacuations of Northern Territories, because they are going to be completely unsupportive and non-sustainable. We are going to see this. There's no doubt about it. We are returning into a Milankovitch cycle, and we are travelling slowly but surely further away from that sun that bathes our planet with its warmth. Now, like I said in the comment section, some people were saying, do you really think that if we are situated on an orbit around our sun 93 million miles away, that an extra 1,000 miles makes a difference? Well, hopefully, with the tilt of our Earth, I've just proved that 1,000 miles already makes a difference for our planet. It puts us in a winter over the northern hemisphere and a summer in the southern hemisphere, and that changes every 6 months as we orbit around the sun. On the Milankovitch cycle, we travel a further 1,000 miles away from the sun, so it will be like the southern and northern and the equatorial regions will be in a winter already, yet we will still be at an angle of 24 or 25 degrees. Sorry, 23.5 degrees, and that will put us an extra 1,000 miles away from the sun. So in the winters, we'll be 2,000 miles away from the sun. So whatever puts us in a winter normally at 1,000 miles away from the sun during the year's rotation will be putting us now at 2,000 miles away. So it'll be twice the winter effects, both on the southern and northern hemisphere, and it's that which will gradually bring, you know, the ice further north. I've give a figure of 40 degrees latitude. You know, we could see the whole of the northern hemisphere above that white. And what that'll do, it will also plunge us further into a more of a winter, because we will have a reflective surface over the northern hemisphere, and it will reflect any radiation that we receive from the sun back out into space. It will only be that when we get the great thaw again of the ice age in another 90,000 years, and things at that time will be completely different to what they are now. That is, if as a species we make it through this, because you know, some people mention, is it an E.L.E. event? You know, is it a life extinction event? It could well be, because just like the magnetic pole reversal, humans may have experienced excursions, but I don't think that we've ever experienced, and I know that people are going to argue with me here, because they say that we've been on this planet a lot longer than 45,000 years, which is what is widely accepted in science as how long we've been as a species of Homo sapiens. You know, I won't get into that argument one way or another, because it doesn't really matter or help benefit the situation that we're in any way. I'll just say this, that we certainly don't have any data that was gathered during the last magnetic reversal on our planet, because we simply didn't have the technology to cover it. We are doing our best at this observatory, as you guys know, recording, and we've got all the data we've ever collected, nearly over 4 years, and we have covered it 24 hours a day, 365 days a year for those 4 years, and at a resolution, believe it or not, of every 3 seconds. So the amount of data we've got on this magnetic reversal to this point is probably more than any other organisation. There won't be another organisation on this planet that has a resolution of every 3 seconds over the last 4 years just dedicated to tracking the magnetic North Pole. And I'm quite proud of that, and you guys should be as well, because without your help we would never have been able to do it. Not only have we got the data at that resolution, we've also, from different locations every 15 minutes at those locations, been recording what's been going on with the magnetic intensity in that region. So like, we've had regular data come from Tucson, Arizona, from Scott. We've got data in Canada that has regularly been coming from Kendall, and we have data that comes in from Jeff down on the east coast of Australia in Perth. You know, so what we've done on the budget we've done a pretty amazing feat to this point. I think you will all agree with that. But you know, we've got a lot more to come. We've got to get into Russia. We have to get into Russia this year, and Brazil. Russia, because it's the epicenter of the northern hemisphere, its intensity is growing. Brazil, because it's in the South Atlantic anomaly region, and we really need to see what levels of radiation are there at the moment. It will give us a good idea as to, when the rest of the world loses its magnetic intensity, what we could be faced with. Now, we really need to see what's the case. in Brazil, you know, it's at a field intensity of about 20,000 nanotesla compared to Russia at 60,000 nanotesla. There's a 40,000 nanotesla difference, and I would presume that Russia is quite well protected at the moment from cosmic rays, whereas Brazil is considerably less protected. And this could be the cause, if we can get all the statistics of cancer rates and cardiac arrests, it might be an indication as to the South Atlantic anomaly is probably fundamentally causing those cardiac arrests and the extra increase in cancer rates. We won't know until we get one of our muon detectors into Brazil and one of our magnetometers, and you know, we will know shortly after that if that is the case, because I would presume that the level of cosmic rays raining down on the surface in Brazil right now are probably 4 times more than what we're seeing in Canada, and probably same for what we get in Australia right now, and here in the UK as well. So we'll leave it there, guys. You know, I always read your comments in the section down there. It's been really interesting over the last few weeks to read some of the new subscribers' comments, and you know, just again, I want to welcome you to our website. Go over to the YouTube channel. Go over to the website if you haven't. There's plenty of stuff on there. If you look in the other section on there, you'll see that we cover a lot of other anomalies. One that might interest you right now, or most of you, will be the sea ice extent, because it hasn't shown any decline in the level of reducing the amount. It's actually from 2021 put on well over now 2 million square miles of extra ice over the northern hemisphere. Again, could be that cut-off point where we go further and further away from the sun in that Milankovitch cycle. Who knows? But one thing for sure is we are now rapidly approaching a time where we could see some changes when we get to that 40-degree mark over the northern hemisphere. We could see the magnetic pole, you know, pick up speed as it goes from the weak field lines, the strong field lines, which slowly allow the magnetic pole to migrate, and then go into the weak field lines where it rapidly migrates. And at that point we are going to experience some interesting climatic events. I will say that, for at least, if anything to go on what we've seen over the last 20 or 30 years as the magnetic pole did pick up its pace. And let's not forget as well, over the last 6 months we've been tracking a slight increase by about 25% of the speed in which the pole is migrating. Remember, it was on average 4.2, now it's at 5.1, 5.2, so there's a slight increase in speed. Maybe it is because we're getting close to that 40-degree mark. We're just going to have to wait and see. So guys, we've cleared up a few things about the Milankovitch cycle, the rotational shift, and yes, this Earth really is unique in its position and its orbit around the sun, and 1,000 miles can affect you know, the climate on this Earth. It makes you wonder how the Earth ever became situated where it was. That's a topic, I believe, for another day. Guys, link down there if you want to help support us. It'd be great to see a few more of you come along and pledge a bit of support for the channel. And also, what I usually do, you know, start to take some time out and think about this, chat about it with your families and friends, and maybe it wouldn't be a bad idea if you put a few provisions away. What harm could it do? Take care of your loved ones. As always, bye for now.